In real-world programs, we often need to manage multiple objects of the same class, like handling a group of students, multiple bank accounts, or a list of customers. Just as we use arrays to store primitive data types, we can also create array of objects. Here you can see that our three student objects, S and S of 0, S of 1 and S of 2, are stored sequentially in memory. Each object occupies its own block of memory and all the three blocks are adjacent to each other. Since we declared them as a normal array, the memory allocation happens automatically on the stack. So when the program exits main, all the three objects are automatically destroyed in the reverse order. Now let's look at the difference between static and dynamic arrays. So in a static array such as student S of 3, that is we created three objects on the stack, one after another in contiguous memory. The compiler automatically allocates and deallocates this memory, so when the function ends, all the three objects are destroyed automatically, as we have just seen in example. So in contrast to this scenario, when we create a dynamic array, for example using new keyword, new student of 3, so this array is now created on the heap. The variable S itself lives on the stack, but it points to the first element of a heap allocated array. So this approach is flexible as we can decide the array size at the runtime, but it also means we must manually release this memory using delete keyword. Otherwise we will end up with a memory leak. So in short, static arrays are simple and managed automatically, while dynamic arrays are flexible but they require manual memory management. Another way to access the elements of dynamic array, instead of using the traditional subscript notation like P of 5 for example, you can use a pointer notation and pointer arithmetic. So pointer P points to the first object in the block. Using the arrow operator P and that arrow operator, we can directly call the member functions or the set data function for that object. For example, P and that arrow operator, and then we can write a function set role. After that, we use P++ to move the pointer forward to the next object in the array. Now let's see a slightly different concept, array of pointers to objects. So unlike normal array of objects, this array doesn't directly store the objects themselves. Instead, it stores the addresses of objects that are created separately usually on the heap. So in this code we declare student asterisk S of 3. This creates an array of basically 3 pointer variables, each capable of holding address of a student object. Inside the loop we use new keyword to create each object dynamically. For example, Si is equals to new student, and so all three objects live in different parts of the heap memory, while the array itself lives on the stack and holds the addresses. So the array itself is stored on the stack and it only contains 3 pointer variables. Each pointer stores the address of a student object created dynamically on the heap. So the objects themselves, student object 1, 2, 3, live at different heap addresses. When we call S of I and that arrow operator show role, for example, we are using arrow operator to access the object that Si points to. Finally, since the objects were created dynamically, we must manage the memory and we must destroy them using delete keyword. Otherwise, the memory will remain occupied.